was messing around with was the Uno. We did a bit of desoldering to get some components, or recycle some components. So that's done. Just for the Arduino, you need to make sure to remember when you are working with LEDs, you need to use the right kind of resistor. Okay, this is a 10K, this is 320, this is a 1K. Okay, this is the LED that you're protecting with these resistors. Because if you actually try to add an LED without a resistor, it's going to blow out the LED. Okay. So, what we were starting was the first example. The point of a microcontroller, you're working with C++ programming in a way, a derived part of C++ programming that the Arduino people developed. You're using that to program and control this microcontroller. That's the point of a microcontroller. So moving the laptop over a bit, because you're going to have to download some code. Okay. And we got a couple pieces so that we could follow along pretty well. We're going to plug this plug in. Take this up. Plug this plug in. Now, if you look at this Arduino now, it's got a built-in LED. The built-in LED is blinking at this point because I ran the blink program on it a couple times. And right now it's showing what will happen with the blinking program. It's going to go on for 1,000 milliseconds, go off for 1,000 milliseconds. In the Arduino IDE, you will find example code for blink in File, Examples, Basics, and Blink. Within that code, you'll see a comment block, a variable block, and function blocks. The comment blocks are notated by a \*, and you will put multiple comments in there. For single line comments, you will put a // For your variable block, that's the variables that you set up in the variable block to work in your functions. You will have a void setup function and a void loop function. All of these are required when you're doing code in Arduino. Void setup has one required object, and that is pin mode. Its params will hold the pin number that you will be using in output or input, whereas void loop is the function that you would use with its directions. To loop through the four objects within its brackets, the first object is for pin 13 on high, which will be 5 volts. It will delay for 1,000 milliseconds, which is 1 second, and that's the second object. The third object is also digital write to pin 13 on low, which means 0 or ground, meaning no voltage, and it will delay for 1,000 milliseconds or 1 second. And this will loop over and over again. This light right here is working as the LED will work. This light is just saying that it's on. Okay, so this light is what the LED should be doing. Now, in order to hook that up, and we turn it off now, this cord makes it kind of top heavy. So we just gonna put that under there. Okay. With this, you're going to be going by the pins. Okay. So you have your analog pins here. And let's see if I have. Okay. So this is the setup of what you have here. Okay. Along this side, you see these individual pins. As you can see, there's one that's blocked off, I believe. And then, alright, one is blocked off here. Then you go to the I/O reference, and that's the very first one that you see across from this second one, and it has the title down there. And it goes down to go reset. This is 3.3 volts. That's 1, 2, 3, 4 pins down. So we have 1, 2, 3, 4. That's 3.3 volts. This is 5 volts. Then you have 2 grounds. Then your VN. Okay. Then you go into your pins. That's your analogs. A0, A1, A2, A3, A4, A5. Okay. Then, so you can see that's the pin setup. As you go to the other side, then it's the same thing. These two are unidentifiable, and they're right at where those pins are. As you can see, there's really no title there. And this starts with AREF on the third pin. Okay, and you see the title there. So we just gonna start from there. So and you see there are these pins as well. The ones with the tildes is your PWN. Those are your pulse modulating systems. I believe I'm saying that right. But those have a specific reason for that tilde. Just keep that in mind. But I was just saying that this is the setup of the pins. Those are the pin layouts. And it's also here, it's just that it's a little bit harder to see. That's why I wrote these out like that. That's it. To explain digital and analog. These are analog. Now, a bit of a tip is analog can also be digital. So you see that the last digital pin here is 13. Okay, it's right. It corresponds right with the LED button that we had. Okay, and 13 is kind of special because if you test on 13 and ground, if you test on 13 and ground, you don't actually have to put a resistor there because 13 automatically has a resistor in it. And is what you use for, well, I guess simply because they want an easy way for you to get started with the Blink program. So, to explain digital, to explain this, it's important to realize that the microcontroller is actually running off electric. Digital means that you're actually getting an electric signal. It's either going to be a 0, no pulse, or ground, meaning no electric charge. So 0 ground is your low. 5 volts is your high. So you're going to see when you get into the programming, you're going to be sending signals to this microcontroller, and it's going to be either low or it's going to be a high, either on or off. The 0 or ground is your low. 5 volts is your high. That's how you're going to go about working a couple things here with the components that you have. Let's go to the Blink program. Okay. This is the mechanical, physical, in this world type thing. The other part is the programming, on the computer type thing. Here's what we're going to do. This is the breadboard that we're going to use with this. Now we can actually do the first part. This is the LED. You can do the Blink program by just plugging it into your ground. Your shortest lead is going to lead up to a flat part in the LED. That's the ground. Your longest lead is going to lead to a skinnier part in the LED. That's your voltage, or your positive, I guess. So your ground is going to go in the ground in this Arduino. We want to put the negative in ground. We want to put the positive in 13. So that's what we're going to do here. Okay. I'm hoping that could be seen. Okay. So once we do that, this LED will echo what the on-board LED was doing that was shown before. So when we plug it in, into the computer, LED is following along with what the on-board LED is doing. This is the on-board LED. This is the LED that we have plugged with the long lead into pin 13 and the short lead into ground.
I am Ebonygeek, and I hope that the information provided has been helpful to you. Please remember to subscribe. Happy building and happy coding.